So after very preliminary sequence stratigraphic interpretation over the well logs in Sambar and Lower Guru formation, all the sequences were calibrated and correlated with the sea level curves of Haq et al. So it was obvious that the sequences had a very good and nice matching with the sea level curves and different events of the sea level curves. Here you can see this is the Lower Guru formation in well number 3, and here is the Sambar formation in well number 28. So the Sambar formation has a complete second order sequence from Sambar 0 sequence boundary to LG 1 sequence boundary, and this second order sequence was overprinted by 4 third order further sequences. And you can see here the cycles of the sediments which is prograding here has very nice correlation with the falling sea level here on the second order, and the third order fluctuations are also represented by the finer beds, by the thin beds in the Sambar formation. However, about the Lower Guru formation, this one is the LG1 sequence boundary, which marks the base of the Lower Guru, and this one is the LG12 sequence boundary. So between these two sequence boundaries, there are 1.5 cycle of the second order. So the lower first order, second order cycle is occupied by the further 9 third order sequences. Actually, LG1 sequence boundary and LG9 sequence boundary, these are the two LG9 maximum flooding surface and LG1 sequence boundary. These two surfaces are bounding the reservoir part of the Lower Guru. So during this study, this part of the Lower Guru was more focused to carry out the research work. Here you can see a table representing the numerical ages of all the major surfaces on the second and third order scale. So these surfaces were converted into the numerical age to carry out this forward stratigraphic modeling. This is the nested sequence stratigraphic framework of the Lower Guru formation across the regional correlation panel. Here you can see 4 wells starting from east to the west. This panel spans about more than 100 kilometers in the depositional dip direction. So here you can see there are 3 bold surfaces: LG1 sequence boundary, LG5 transgressive surface, and LG9 maximum flooding surface. So these are the major second order surfaces where the events of the second order and third order synchronize with each other to give very pronounced effects on the sediments. Here you can see from LG1 sequence boundary to LG5 transgressive surface, the sediments, there is an overall prograding behavior of the Lower Guru formation in this package. And from LG5 transgressive surface to LG9 maximum flooding surface, there is overall a fining outward behavior of the Lower Guru. And if we talk about overall second order sequence, LG1 to LG9 maximum flooding surface, there is an overall fining outward behavior in all of the wells interpreted here. So this behavior of LG9 maximum flooding surface, where the gamma ray has a very pronounced high gamma ray effect, is very obvious in most of the wells in the lower Indus basin. So this is actually a regional maximum flooding surface, and this regional maximum flooding surface can also be interpreted as a downlap surface in most of the seismic data. So this is a diagram which I have taken from my paper published in an international journal. So here you can see these are same 4 wells I have shown in the previous slide. In these 4 wells, we have interpreted the facies correlated with the sequence stratigraphic surfaces and parasequences. The second order low stand system of the Lower Guru from LG1 to LG5 transgressive surface. Here you can see the eastern side of the wells have fluvial deltaic sediments with very nice thick beds of sands, whereas in the western side, which is about 38 kilometers away from well 8, there are coarser sands in the bottom, and then above these coarser sands there is no thick sands. So it means this is a basinal side, and these coarser sands are related to outer shelf turbidites, you can say. And above LG5 sequence transgressive surface, as I have told, that this package from LG5 transgressive surface to LG9 maximum flooding surface is a package which is an overall retrograding behavior. So these packages are characterized by the estuarine sediments and retrograding fluid deltaic sediments and retrograding shelf and shore face sediments. This is another picture just to show you the behavior of the lower Guru in nine third order sequences. These are actually the sand bodies which has been estimated from the net sand analysis of all the lower stand system tracks in 9 sequences. From this first one picture, A, B, C, D. A is the oldest and I is the youngest picture in this slide. So A, B, C, D, and E is representing actually the prograding behavior, which is the second order prograding behavior of the lower Guru formation. So here you can see the sands are moving from proximal side. Proximal side means land side to the basinal side. Land side is to the east and basinal side is to the west. So from A to E, the sands are actually moving towards the basin, and from F to I, the sands are moving towards the land. So it means from A to E, there was an overall progradation, and then there was an retrogradation. So here you can see the sands are very confined to the eastern border of the study area. So it is a gross depositional map which was published in the same paper. Here you can see actually this map is I am showing you this map to just show the direction of the sediments. So because direction of deposition is required for the forward stratigraphic modeling, here you can see the map is showing you there is a red boundary in between the map. To the west there is a more marine sediments, and to the east there are fluid deltaic and shelfal sands characterized with the deltas and estuaries here, and coastal sand linear bodies. The thickness of lower Guru has also been plotted here. It is an isopack. The thickness in the eastern side of lower Guru is about 1500, and it decreases to the west to around 400 meter. Here you can see these are the possible basin floor fans. These have not been drilled, but there is a possibility of the basin floor fans in the eastern side, western side of the area. But these turbidites have been drilled. As you can see, it is well 6, and these turbidites are proven here. Okay, sir. I will go quickly. This is the sequence stratigraphy of the lower Sambar formation. So Sambar formation is occupied by 1 second order sequence and 4 third order sequences. Here you can see very nice sands here, but these sands are tight and they have a porosity of about 5 to 6%.